Okay, so today we're going to prove the triangle inequality theorem, which states that for any x and y contained in the real numbers, the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. And in order to prove this, I'm going to use three properties of real numbers with absolute value. I know that the absolute value of x is equal to the square root of x squared. I know the absolute value of x squared is equal to x squared. And I know the absolute value of x is always bigger than or equal to x. I might show the validity of these three properties in a separate video, but for now, I'm just going to assume these three properties in order to prove the triangle inequality theorem. And of course, off to the side, we'll put the actual definition of the absolute value of x, right, for any x contained in the real numbers. This is equal to, so absolute value of x is equal to x if x is bigger than or equal to 0, and it's equal to negative x if x is less than 0, right? So if we have a positive number inside of here, the absolute value of that positive number will just be that positive number. And if we have a negative number inside of here, then the absolute value of that negative number will be negative of that negative number, right? So for an example, if I had like the absolute value of negative 3, that would give me negative 3, which would make it positive, right? So that's sort of how, that is how the absolute value sort of works, right? And if we had the absolute value of 5, right, since 5 is positive, it would just spit out 5, right? So just sort of a little refresher. So we can use all of these ideas in order to prove the triangle inequality theorem, right? So let's go ahead and start the proof. So we're going to start with the absolute value of x plus y, but we're going to square it. And the reason why we do that is because the absolute value of x plus y squared by number 2, right, is equal to x plus y squared, right? The absolute value of a number, absolute value of x squared is equal to x squared, right? So the absolute value of x plus y squared is just x plus y squared. Using some algebra, this is equal to x plus y times x plus y, right? And this is equal to, so x times x is x squared, x times y is xy, and y times x is xy again. So this will be 2xy. And then y times y is y squared. Now, we're going to use number 3. So this guy is less than or equal to x squared plus 2 times the absolute value of x times the absolute value of y plus y squared. Because we know the absolute value of x is bigger than or equal to x, right? For number 3. And the absolute value of y is bigger than or equal to y, which is what we have here. And using number 2 again, we know this is equal to absolute value of x squared plus 2 absolute value of x plus absolute value of y squared. And then sort of going backwards, right, using the same idea we used up here, we know this guy is equal to the absolute value of x plus the absolute value of y times the absolute value of x plus the absolute value of y, right? And, right, absolute value of x times absolute value of x is absolute value of x squared. Absolute value of x times absolute value of y plus absolute value of y times absolute value of x is 2 absolute value of x, absolute value of y. And we have that absolute value of y times absolute value of y is absolute value of y squared. So we know this is equal to this, and this is equal to absolute value of x plus absolute value of y squared. So look at what we have. We have, so thus, we have that the absolute value of x plus y squared is less than or equal to, right? Less than or equal to the absolute value of x plus the absolute value of y squared, right? So since both of these are positive, right, this implies that the square root of x plus y, or absolute value of x plus y squared, must be less than or equal to the square root of the absolute value of x plus the absolute value of y squared. And then using number 1, right, we know that the absolute value, or we know that the square root of something squared is the absolute value of that thing, right? So from number 1, this implies that the absolute value of the absolute value of x plus y is less than or equal to the absolute value of the absolute value of x plus the absolute value of y, right? Notice in number 1, the absolute value of x is equal to the square root of x squared. So in this case, we had the square root of x squared, right? The square root of something squared is the absolute value of that thing, right? From number 1. And now we're going to use the definition of absolute value. We know that the absolute value of the absolute value of x plus y is just going to be the absolute value of x plus y because we have the absolute value of a positive number, right? Of course, the absolute value of x plus y is going to be positive. So the absolute value of a positive number is just that positive number. But you can see inside that absolute value, the positive number is absolute value of x plus y. And this is less than or equal to the absolute value of the absolute value of x plus the absolute value of y. Absolute value of x plus absolute value of y is going to be positive. So the absolute value of that positive number is just that positive number. And look, we've proven that the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y using just these ideas, right? And that is our proof. And of course, the triangle inequality theorem is so useful to us in calculus and real analysis and stuff like that.